Assalamualaikum warahmatullahi wabarakatuh, and good day everyone. So this is a video of an exercise of Fadum methods in order to solve the vertical stress at the center of square, at point A. So note that this is a rectangular footing with a 2 meter times 2 meter of square hole. So it has hole in the rectangular footing. So the hole is located 1 meter from the left edge, and it is equally positioned between the top and also the lower edges of the footing. And the contact pressure under the footing is 500 meter kilopascal, uniformly distributed. So we need to use the Fadum method to compute the vertical stress at A, with the location of Z at 2 meter below the center of square A. So the Z now is 2 meter. So I hope you still remember that the Fadum concept. So any point that we interested to define must lies at the corner of at least at one corner of the rectangular that we want to use to define the influence factor. And influence factor. So let's start. So as we could see, this is a symmetrical. So either you want to use at the top or either you want to use at the below of rectangular as our reference. So at the end of the process, we have 2 times 2. Okay, so let's start our solution. So, okay, and in color. So as I mentioned before, that we can take the rectangular as a 2 different parts because it is a symmetrical. So let's say we have this one, and because it is identically similar, so this is point A. So this is where we have the 500 kilopascal. Okay. So what we would like to do is, first usually we have to label the square that we interested to use in we finding the influential factor. So that's why so we need to use the label. So in the question, they already give you the A, B, C, D, so and E, F, G, H, I, D, A, and J, K, E, A. So all the square is related to A point. All the square is related to A point. So it's already obey the first principle of Fadum, which at least one point is fall on the corner of a square that we want to define the influential factor. So here is B. Okay, B, C, and D. So we need to define. Let's say this is the biggest one, so I would like to start with this one first. So what is the length? So of course 5 meter minus 1 meter here and also 1 meter here. So this is 3 meter in the distance. And another for the width, it is 2 meter. So actually we can start to build a table. table to calculate the to define the inflation factor in much more easier. So for the square, first is for the square ABCD. So what is B? What is L? So of course this is 2 meter and 3 meter. So M is B over Z. So 2 divided by 2, you got 1. And N is L over Z. So of course 3 divided by 2, so you got 1.5. So what is the influential factor? So you read it from the Fadum graph. So N is 1.5, so 1, this is 2, so 1.5 is around here. So bear in mind that the axis of x for the Fadum graph is a log graph. So 1, 2, 3, and 10. 3, 4, 5, 6 until 10. So 1.5 or m, and m is 1. So m is 1 is here. So basically it might be have around here. So either you want to read to the left or to the right. So influential factor is here actually 0.15. So basically and it increased 0.01 each level. So 0.16789 0.195. So influential factor you got 0.195. And so for the stress of this square, so you have a 500 times 0.15. So later you define how much the stress, and we do that next for the let's say we calculate first for the rectangular that have a pressure on it, have a pressure on it. So let's move to the A, H, I, and B. So it also have a 500, and later on we will minus this one and also this one. So for the rectangular that having a value, so it is A, H, I, B, A, H, I, and B. So what's the value of L and W? So L and V. So let's say this is still B. So of course it is 2. And this also 2 meter. So B is 2. And also 2. So M is 1. And also 1. So 1 of N. And also 1 for M. Okay. Let's say here. So 0.15678. Okay, so you got 0.018. So similarly, we have a value of 500 kilopascal times the 0.18. So you get the answer here and also this here. Okay, so usually I easily put the symbol of positive symbol for this one, positive symbol also for this one, because we want to include this one, and it has a loading on it. And for the area that doesn't have any loads, you want to put a negative symbol here, another negative symbol for the next one. So let's do for the right first, and then the left one. So it is actually in the similar size. So if you expert and you just want to calculate one time, also can be done. But for beginner, let's say we don't want to have a confusion, so let's do for the both square. So it is a G E N F N E F N E. So the length is 1 1. So that's why this is 0.5, also 0.5. So you got the value of influential factor is 1 2 3 4 5, and M also 5. Say here. So you got 0.095 maybe. So it says 0.095. So negative times 0.95. So similarly for the next one, let's say it is for the B. So similarly, this is AJKE, and 1 meter also 0.5. Similarly, 0.5 and 0.095. So similar. So from here, okay, as I mentioned before, we do this symmetrically. So that's why for the total, oops, oh, forgot to take the pointer. Okay, for the total, okay, for the total stress, yeah, and erase this first. Okay, alright, so for the total, as this is symmetrically, so let's write number 2, and let's total up the first one, 500 times the times 0.195 plus 500 pressure from the next side of the square, next square or rectangular, and minus the square, 500 times 0.095, and also 500 times 0.095. Okay, close the bracket. So means this is so this is for A, B, C, D. This is for A, H, I, B. The next one A, G, F, E, and also this one A, J, K, E. So note that every of the rectangular or square have a label. So means it's obey the Fadum. And from here you times 2 because you calculate only at the top side of the foundation, but actually you have another half. So I think that's all. Get the value and you will define the vertical stress. Thank you. Okay, so see you in next chapter. Assalamualaikum.